All right, this next section is 1.4. It is not on the exam, but I need to show you how to do it. There's pros and cons to having it this way, waiting till now to do it. This is called the delta epsilon proof, or the definition of the limit. Uh, 1.4 definition of the limit. A little bit of notation. We use this throughout this. This means for all. This means there exists. I think I've shown you those two before. And then triple dot means therefore. That's math jargon. Triple dot in like a triangle shape. So we're looking at like limit as x approaches a of f of x equals some value L. What this means is like intuitively or like in words, like as x gets closer to a, f of x or L gets f of x gets closer to L. So let's say that's my f of x function. So let's say there's a little window around A. As x gets closer to A, it could be coming from the left or from the right. We're going to call this width here delta. That width is delta. So the right side is A plus delta, and the left side is A minus delta. So where the equivalent over here, we'll say this distance here is like epsilon 1, and this distance here is epsilon 2. So this is L minus epsilon 1 and L plus epsilon 2. Now, if you're lucky, some graphs like y equals mx plus b, straight lines, epsilon 1 is the same thing as epsilon 2, but they don't necessarily have to be. We're going to restrict what we're doing to just straight lines. We'll do this. So Can you guys see that as like delta gets smaller, let's say it moves in half the distance, it's right here and here. My window around L gets smaller also. Does that make sense? As we move in more this way, this squeezes in towards L. And so that when delta gets to 0, delta equals 0, and if the function exists, the distance is 0, we are just flat out on the line. And we get f of a equals L. So remember, limit is like we're moving in along the line. We're moving closer to the point. Does that make sense pictorially or graphically? Now, give me another 15 seconds. The official definition of the limit is the most god-awful proof. It's called the delta epsilon proof, named after this. Oh, I'll spell them. That's delta, and that is epsilon. It's a lowercase delta and a capital case epsilon. They're both Greek letters. Yeah.
The uppercase delta is a triangle.
What?
Uppercase delta is that the triangle? Didn't they teach us in like high school the triangle with delta?
Yeah. Yeah, uppercase is the triangle. Like dy delta y over delta x is changing y over changing x. Yeah. All right. So the official definition of a limit. Definition of limit. The limit as x approaches a of f of x equals L means that for all epsilon greater than 0, and so sometimes you'll see the triangle upside down A here. For all epsilon greater than 0, no matter how small, like smaller, the better. Doesn't matter how small epsilon gets, there exists a corresponding delta greater than 0. And for there exists, I could have done that backwards E right there. Such that if zero is less than the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. I'll give you a second to write that down, and then we'll go back and look at the picture and see how this applies. And then I'll show you how to do this. This is one of those lectures that if I wanted to do the full thing, it could take like 2 hours easily. Seems like a huge time sink since after you do it, you never use it again. It's really important if you're going to be a pure mathematician. This is like the idea of how proofs work. So we come up here and we look back at the picture. It doesn't really matter where I pick epsilon to be. I can come over here. Let's say it's epsilon 1. I can come over here and find a delta that's greater than 0. That's that distance away from f of a. So x minus a, like that x minus a, this is the distance x minus a. X minus a is a distance. And f of x minus L is a distance. So when you're doing these, this comes in 2 parts. We're going to have a discovery phase. And in the discovery phase, we find delta in terms of epsilon. Then B, we go through the formal proof. You're going to find when you're doing this, if you try one out, it's kind of like working forward and then working backwards. Like the formal proof is almost like working backwards. So the formal proof involves, we will prove that the absolute value of f of x minus L is less than epsilon by starting with 0 is less than x minus a, which is less than delta. When f of x is a line, this is very easy. So if I have time, I'll show you 2 lines today. If not, I plan on making a video. I also have a quadratic function here to try, but that would be a video. It's a little bit harder. There's more stuff going on. Anyone need this up longer? Okay. Remember, we're going over the practice exam on Thursday. The test is next Tuesday. And I'll be in the Mesa Center on Visalia campus on 9 to 12 on Saturday. And I'm on Zoom from 9 in the morning, at least till 10 in the morning on Friday. And if someone hops on, I get back on and I'll be on till 11. On Zoom on Friday. So you got time to ask more questions too. Like Saturday is probably the easiest for most people. Unless you have work on the weekend, then you're fucked. But all right. Let's do it. We are going to prove that the limit as x approaches 4 of 3x minus 7 equals 5. Now, while you're learning how to do this, it's kind of handy to have the other forms listed. Like the generic form is limit as x approaches a of f of x equals L. And then we're looking at 0 less than the absolute value of x minus a is less than delta. And we're looking at f of x minus L is less than epsilon. So we need to kind of like pair all this shit up. So 4 is my A. That's my f of x. And that's my L. So we're starting off with if 0 is less than x minus a absolute value, less than delta, then absolute value of f of x minus L is less than epsilon. Let's plug in what we know. 0 is less than the absolute value of x minus a, which is x minus 4, is less than delta. Then absolute value of 3x minus 7 minus 5 is less than epsilon. That's all we had. All we did is plug shit in so far, right? So this is 3x minus 12 is less than epsilon. And I can pull out the 3 by factoring it out, and that is 3 times the absolute value of x minus 4 is less than epsilon. So if I divide by 3, I get the absolute value of x minus 4 is less than epsilon over 3, or 1/3 epsilon. And now, doesn't this look like this? We know it's a distance. So by default, distance is greater than or equal to 0. It's got to be. And we're not actually picking at x equals 4 because that's not the idea of a limit. So it's the same setup. So the only thing that's different is I've got delta there and I've got epsilon over 3 here. So we will pick delta to be 1/3 epsilon. Or we can pick any delta less than or equal to 1/3 epsilon. So our formal proof, we start back at the beginning. That's what we were discovering. This was our discovery result. So our formal proof. Given an epsilon greater than 0, there exists a delta less than or equal to 1/3 epsilon. such that for all epsilon, if 0 is less than x minus 4 is less than delta, then 3x minus 7 minus 5 is less than epsilon. We start with a statement in the proof, and then we prove the if. And we start on this side, this one, we start with f of x minus L, and we got to zero, the delta one. Now we start on the delta side and we go to the epsilon side. I can multiply that by 3. And I get 0 is less than 3 times absolute value of x minus 4 is less than 3 delta. And 0 is less than 3x minus 12 in the absolute values, which is less than 3 delta. Finally, we write it in the form that's in the f of x minus L format. Is less than 3 delta. But that's less than or equal to 3 times epsilon over 3, which equals epsilon. So we have this chain of less thans. This ends up being 0 is less than absolute value of 3x minus 7 minus 5 is less than epsilon. And then they say QED. QED is Latin. It's something like this part is something like thus demonstrated or something like that. What it means is proof is done. Sometimes they put a little box. Fun, right? Can you imagine doing this like the second week of lecture? That's what this corresponds to. 1.4 was like the second week of lecture. We did 1.1, 1.2, 1.3. Second week of the end of the second week of lecture is 1.4, and just dropping this fucking giant math jargon on you without any like a whole lot of pictures going on, shit like that. It is worth noting that we can pick a lower delta. We had delta was less than or equal to epsilon over 3. Like if we do delta is 1/6 epsilon, which is like half of 1/3 epsilon. The inequality string at the end, where we had is less than 3d or 3 delta, less than or equal to 3 times epsilon over 3 equals epsilon. This changes to less than 3 delta, which is less than 3/1/6 epsilon, which is 1/2 epsilon, which is less than epsilon. So the proof still works. You can pick any delta that, as long as it's less than it. But we use the 1/3 one as a line. All right, one more. Prove the limit as x approaches 3 of 2x plus 1 equals 7. So our discovery phase, this setup, that's my A. So this is 0 is less than x minus 3 is less than delta. And if we do the f of x minus L, I have 2x plus 1 minus 7 is less than epsilon. So 2x plus 1 minus 7 is the same thing as 2x minus 6. And if I factor out the 2, I've got 2 times the absolute value of x minus 3 is less than epsilon. And if I divide by 2, I have absolute value of x minus 3 is less than epsilon over 2, or 1/2 epsilon. This setup matches this setup. They match if delta equals 1/2 epsilon. So that's what we're going to assume in our formal proof. Given epsilon greater than 0, there exists a delta equal to 1/2 epsilon, such that for all epsilon, if 0 is less than the absolute value of x minus 3 is less than delta, then 2x plus 1 in parentheses minus 7, all of that in absolute value is less than epsilon. We have this blanket statement here, and that's what we prove in our proof. And we're basically working backwards. So here we can multiply by 2. I get 0 is less than 2 times x minus 3. It's less than 2 delta. Zero is less than the absolute value of 2x minus 6, which is less than 2 delta. Zero is less than the absolute value of 2x plus 1 minus 7, which is less than 2 delta, which equals 2 times 1/2 epsilon, which is epsilon. So 0 is less than the absolute value of 2x plus 1 minus 7 is less than epsilon. QED box. That is the delta epsilon proof. It's not a whole lot of fun, even just doing the line. When you start having things like quadratic formula, or not formulas, but quadratic functions and harder things, this becomes a bigger pain in the ass. I'll make a video for you guys later on showing quadratic function, doing a limit so you can see what it looks like. Other than that, that's it for lecture. Try to get your homework done before Thursday and try to do the practice exam. Some of you are probably pretty close. Some of you have got a long way to go.
Adios.
Adios, GTFO. Get the fuck out. You don't have to go home, but you can't stay here. Not what they say at bars? Well, you can if you want to